Hi, welcome back to my channel. Hope you are doing good. Today I'm going to talk about Kubernetes hands-on session and which is of part 3. So we will try to understand what is NodePort and what is load balancer kind, and we will see some demonstration how this really works in the Kubernetes engine. So Kubernetes manifest file we have understood about part 2, various kinds we can write it, and we can test it our applications. So in this particular exercise, I'm focusing on the Kubernetes manifest file real-time exercise 1, which is of a kind pod and the service type of load balancer, whichever the applications, the front-end applications over the web or over the CURL based, which can communicate with the service which will talk to the pod and gets the data for us as a HTTP request. That is the exercise 1. And the other one is exercise 2, which is going to talk about the deployment kind. So basically deployment is combination of replication controller and pod. That means whenever you do any deployment of the application based on the replica sets which we say, it will create those many number of pods. So that is the significance of deployment which will give you, and also it will give you, in case of a pod failure, automatically the new pod will be self-healed on behalf of the failed pod. That we can see in hands-on session. And here also I'm using the service type load balancer kind types. So kind types node port. Kubernetes will allocate a specific port on each node to that service. That means any request which we are coming, if I say that type is node port and the port which I am specifying, that port is going to be allocated and called to that particular service and serves for us. Load balancer is something which is a network oriented related service kind. What happens, it depends on the cloud provider to cloud provider. So it will generate a external IP address. That external IP address we always map to the service so that the request will be routed. So this exposing is a very important, but the advantage over node port is tagging to each node, but load balancer is not like to each node mapping. Within the single node also, if we have more than one pod, the request can be delegated to the every pod based on the client types, like a browser client or CURL client or any REST client. If it is wanted to access our service, yes, it is. We can see the demonstration. So this is a typical, uh, look, the architecture look like how the request will be coming in, either incoming request through web or CURL or from other, client side, whatever it is. And here you will have either load balancer or NodePort and cluster. This is a Kubernetes cluster which is going to have a service. Underneath service we will be hosting pods. So as I said, I'm going to here demonstrate the load balancer. So let us try to understand the manifest file. So here Java web pod, I created one manifest file. Here kind is pod, metadata is Java web, and labels is this. This is the actual label for the pod which I'm creating, and the specification is it is a container type, and the name of the container is Java web, and image I'm pulling my Spring Boot which is available in the Docker's hub, which is public. If it is available, that image, don't pull it. If it is not there, you pull it. And I'm setting the binding address and resource limits. So I'm specifying the how much request for the resource I wanted. I'm specifying that 100 milli CPUs. This M stands for milli CPUs, and memory is 100 MB, which I'm going to allocate to this container, and the ports are which is going to run on 8080. So this is a pod deployment manifest file. Now look at the service deployment manifest file. Now you see that API version is 1 and kind is service. Here kind is pod, here kind is service. I am giving a metadata name as a Java web-service for significantly to understand. And the specification is the type is load balancer. So I am specifying the selector which pod I am going to call whenever any request comes from the web or any client. So I'm specifying that to go ahead and look up from this label match. So this is the label match which is declared in the pod. And the ports protocol is TCP and port is 8080 and target port is 8080. So this target port is basically the container port. This port where we are going to access it. So this is a typical pod and service load balancer. Now let us look at the deployment based manifest file. So here app version is apps. So this certain syntaxes we must follow, and kind is deployment. You can see that here I'm declaring that Java web-deployment is the name of the metadata for my deployment, and I'm specifically declaring a label Java web-replicas. So this label is applied to deployment kind, and here I am specifying selector. In this selector I am specifying that match labels. This match label which is going to match ideally app.kubernetes num. This is the declaration. This is also saying that Java web-replicas. That means this deployment is going to host a replica set as well as a container. So to define a replica set, we have to use replicas. This is the one. So here I'm specifying I wanted 2 pods and I'm declaring my container as a template. So I wanted my template, and template has a label. That label is matching with this. So this is the label which is going to look up by this match label. And then I have specification for my container, and name of the container is Java web, and I'm pulling it, and the resources requests and container port is 8080. So this label is matching here. This label, whatever the metadata label for the deployment, is going to match with the service. Now we can see that we have service 2.yml. So this is a service kind, and I'm specifying metadata name as service 2, and the specification type load balancer, and selector I'm specifying Java web-replicas RS. That is going to match with this. This label is matching here. Whenever I look for the 8084 service on that specific port, which is going to look from this deployment, and the target port is 8080. So this is the 8080 port. This deployment is going to run it. We will see the demonstration. This is a typical Kubernetes deployment where we are running master node and slave node. Slave nodes basically host the pods and the associated services. So in my machine I am running, and also 8082 to 80, 8084 to 80. Here I did not write that. So this is a Docker public registry image access Kubernetes locally up and running. That is a Minikube and Java developers. So these are the help links. So now let's get into the real hands-on session and try to understand how to create a resource of any kind type. So now I have a namespace which I have created earlier. Now I'm trying to see is there any resource available. No. Now, as I said, I am going to create exercise 1. The exercise 1, as I said, Kubernetes ctl-n. I'm going to use the same namespace. Then create is the command. Then I specify -f followed by the pod. Now I'm creating the resource in this namespace, that is ns-realtime. Now I'll try to issue a command. Can I get the pod? I can see that pod has been ready. That is 1 out of 1, and it is running. and just restarts nothing, just 9 seconds old of the age of that pod. So now I have to create the load balancer port, that is this. So this is the one pod is running. Now this service is going to consume that service. Now let me issue a command and see what are the resources which I have created. Now I said in the PPT that it is external service is creating as a load balancer type. So here you can see that this is the IP address generated. And what is the port? This is 8080 is the port which is running my basically the service. Now let me do a log inspection of this pod. Whether it started successfully or not, we can see that it is working, but let's try to see it. Now we can see that it's just started, but there is no request has been received. So now let's go ahead and access this, typically the CURL client followed by 8080 is my port which is running. So this is going to consume my Spring Boot application data, which I have created image and then whatever it is, the REST endpoint. It is working. Now I'll try to see the log, whether is there any change in the log. Yes, my Spring Boot started on an 8080 port before it was there up to started log message. Now it is initialized dispatcher servlet. That means request served. That means my pod is up and running. My service is also good. I am able to test it. Now can I able to test from new browser? That is what I wanted to see it. I'm creating a new window. Saying localhost, then it through which I'm doing a Kubernetes forwarding related. So that means maybe the pod has been, the port forwarding may be killed. The port already killed. So I'm doing a port forwarding because I want to test my application. Because of that, and it is not clean. Now I'm port forwarding. Now I can see that this is home page. That means now my application, I'm able to access it from the web browser. So this is exercise 1. Now let's go ahead and do the other kind of a deployment. Now what I'm going to do is I'm going to use deployment. So this is the resource which is going to create the deployment. Now you can see all the resources. Now I have created a deployment and up to date available to, it is to ready out of ready. That means this one for Java web deployment. The name of the deployment is, this is the name. So followed by unique number which is assigning by the Kubernetes engine. So both pods are running. Now let me go ahead and see the logs for that. So now I'm going to issue log checking command. So this is also started, which is running on 8080 support. Okay, successfully started. Now let me see the other log. So this is the other pod which is available in that. Now this is also started successfully on 8080 port. That means there are 2 pods which are up and running. So there is no request as of now served. Now what I will do is I need to deploy the load balancer service for accessing those pods, right? So I'm deploying now. So now service 2 has been created this resource. Now let me get all. let me clear the screen and then I demo it. So if you look at typically, I have a deployment, I have a service 2. This service 2 is going to serve these two ports whenever there is a request is coming in. And my service is running on 8084 is a port. So what I'm doing is I'm going to issue a client. This is client's curl, nothing but one of the client. I take the external IP. I use 8084 is the port. So I received the REST response from my service, but I don't know which port serve. So what we can do is we can go ahead and do inspect. Let me try to issue this command. That means this pod did not receive the request. This one did not receive. Probably the other pod maybe received the request. Let me see that. What is the other pod? This is the other pod. Probably received the request to serve the client. Yes. Yeah, we can see that initialize dispatcher servlet. This is served by this pod, that is this. Second pod served my request from the CURL client. Now let me try to test it from web browser. So what is the web browser port? 8084. Now this is also typically is not working because the port forwarding may be failed. So I'm reinitializing my Kubernetes. Now I can able to access out of my Linux service of the Kubernetes engine outside. So this means now this is serving. Now this is a client 2, which is a browser. Now let me go ahead and check whether who served that request. Yes, previously we saw the message until started. Now we see that this is initialized. That means now my request has been served by both the pods. This is served for this client, that is CURL. This is the browser client is served by this pod. That means my request is being balanced. So one client, that is URL served by pod 1, the other client browser served by pod 2. So that this is the typical exercise wherein we wanted to establish. Let me try to kill a pod. What happens if I kill my pod? Try to see that. I'm going to kill, delete. This pod I'm deleting. What happens? I have clearly specified I need 2 pods, right? So that is what my deployment instruction is saying. Now can I see what happened on behalf of the killed fail? Say by default any failure can happen in the real time. So if it happens, can I see new pod generated on behalf of or not? We will see that. Now I can see that there is a new pod which created on behalf of killed pod. This is the pod which I killed it. There is a new pod generated. Now take this and look at the log. Just started the new pod. If I hit the same URL, whether it's going to serve or not, we will see that pod. Here, again, this load balancer link connection. Okay, this is fine. I don't know what is the reason. Now I'm hitting it from the browser. Let's wait and watch what is happening. Whether this is really serving for us or not serving for us. This is for the Java pod service. This is handling connection. Because this outside of accessing is a bit a challenge. Otherwise, if we wanted to use the curl, it is just possible to do it. issue log. Is there any request served? No, there is no request as of now arrived to this. So let me get this. Typically, what is happening? We'll see that. So still this is not serving. Let me try to open it from the browser window. Because of this already looks like, I think there is an issue is happening. So this is the reason. Let me do this port forwarding. Ideally, this port forwarding is here, but due to Minikube instructions, we need to follow that route. So now you can see that the page has been served. Okay. So don't worry about this forwarding. Okay. Port forwarding is really not needed. Okay. In the real environment. But in this particular case, it is needed because we are going with multiple tunnels and all. Okay. So now let's go ahead and inspect whether this is by this or the other. Maybe the other pod. So which pod is that this was killed? Probably this one was served. Let's go ahead and hit from other client. So now I'll hit with this. So now I got the response. Now we will see which pod served. JVM running. Looks like the same pod is served because this port forwarding is one of the worriness which is causing these issues. Because of that, the request not yet served by this. Let's try to test the same thing from this browser. So at least is there any load happens on that? Okay, now let's see which port served my request. So still it was serving the old port because of this port forwarding related issues. Otherwise, usually this will balance. You have seen in the previous case. Okay. So that is how this will work. If I kill a pod on behalf of the killed pod, there will be new pod will be launching by Kubernetes engine. That's the advantage when you are dealing with Kubernetes orchestration platform. So I hope you enjoy this video. Like it, share it, and subscribe it. I come up with Ingress kind with part 4 lab exercise. Until then, see you. Bye bye.